Hi, welcome back in the course of Python. And in the last lecture, we just had a general introduction for Python, and we did some basic commands for Python. And now I would like to introduce in Python that there are some libraries that are the part of Python. And these libraries are very essential if you want to do the data analysis, if you want to do really some work, then these libraries are important. So today we are going to discuss two main libraries, and we will see what are those. Let's look at the first one. What are those? Let's look at one. First of all, you need to know what you want to do with the Python. First of all, that you have some data, and your data is in table form. Okay, for example, you have pressure versus time, or you have flow rate versus time, production rate versus time, water production versus time, gas production versus time. So you have a lot of data in tables. Usually the Eclipse generates lots of data. Now these tables has to be uh, shown in the Python in an organized way. Well, how you can share those tables in an organized way and how you can use those tables, you have to use the NumPy for that one, NumPy library, and we will learn that how we can do that. Then in order to solve this calculus, differential equations, and partial differential equations, so all the mathematics, scientific computing is done using the Scipy. Then let's forward we have pandas, and pandas is actually for developing the using the machine learning algorithms and using those data which is available in NumPy and Scipy, especially in NumPy, and developing the tables and graphs and figures and so on. So let's start with the NumPy. What is NumPy? NumPy is actually, if you have the long data you want to show in the matrices form, or so you can really use this NumPy module. So because it can store the numbers and data in the arrays, in the style of arrays, multi-dimensional arrays, and usually it is used in as one mathematics, which is also needed in our case. And in the after we finish the introduction, we will directly jump to use the basic commands of NumPy. Then, as I said, for linear algebra, differential equation, numerical integration, optimization, you name it, all scientific computing is done using the Scipy. Then we have the pandas. For example, you want to do these tables, graphs, and using this NumPy, and so pandas actually helps you to develop those graphs and tables out of it. Then we have the scikit-learn, which is you can use this machine learning algorithm which classify the regression and mode validating. So all these are important for petroleum engineers to learn. And when we will first start with the NumPy, and then we will learn with the Scipy and the matplot. So this was the general introduction, and we will go ahead with the NumPy now and learn about it, that how it works. In order to run this Scipy and NumPy, we are going to use this Jupyter actually, which is the program for Python, and we are going to use the Jupyter for using this Python. So here it is opening now. Here it is the command. So let's start with the first command, and I will show you that how it works. So before you start any library, you want to use this NumPy, you want to use this SciPy, you want to use the pandas, or there are many hundreds of other libraries that you want to use. So first thing you have to write here, import NumPy as NP. This should be your first command. So what you are doing here, you are importing the NumPy library as NP. So whatever command you put in the next, it will import the basic library from there. So let's start with the first command. We write here a is equal to np dot array, and then you make like this. Whatever arrays you want to put, now this is your array, and then you write percent a, so and then you simply run it. Now you see that your numbers are here. So now for example you have the pressure data, and your pressure data starts from 200, 2000 to 3000, so 2000 to 2100, 2300, this one. Okay, you run it. Now your data is safe. You can do the multiplication, you can do the division. You can, if you want to take the log, you can take the log. So you can use actually the data that you have in your arrays using this one. So that's why it is important, because this, using the tables, actually you can use, play with all the data and come up with what you want. And for example, your data is in hundreds and thousands, so you can use in another way, which I will teach you after we start finish the basic things. Then we will go for the big data, that how we can manage the big data in this one. So this is just the first command. So the first command is array. Note it down that the first command is array and objective is to store the data. And now we will play this array and see how it all works. Now let's look at the another command. First command we discuss is the array command, np.array. And now we are discussing the another command, which is the a.reshape. What we are doing, we have this array and now we are just reshaping. Look at it. We have 8 values, 1 2 3 4 5 6 7 8. And now what we did, we put 2 lines and 4 in each value. So now we can put 3 lines and 3 in each value and we can run it. It is showing error because the values are not fit according to this one. So for example, if we have 2, here it's 4, it works. Okay, now you want to do 3 lines, 1 2 3 4 5 6 7 8. It should be 9, 3100. So now you can put 3 lines, 3. So you run it, it gives you the data like this. Now for example, you want to run 4 lines, 2 2 4 6. Now you see 1 2 3. It is showing error. It was showing error because if we have the 5 lines and each we do total values is 10. So here it should be 10. So whatever you are reshaping, you make sure that whatever numbers you are here, they should, when you multiply both of them, they should be the same. For example, there should be 5 multiplied by 2, should be 10 values. So 1 2 3 4 5 6 7 8 9 10. Now for example, you want to make 2 lines and each of them 3 4 5, so should be 5. So now you see 5, it works. So this data actually is used later on, for example, and each data has its own unique address. So you can call it and use it accordingly, whatever you want to do with it. And we will see in the upcoming commands that how we are going to use it. Let's look at it now. What you want to do, you want to multiply all with 5. So now you will see that this is b, and now you multiplied each by 5. So now you can see the values multiplied by. Even you can add more. For example, this is your calculation. Let's see, now it added the 4 into the value. So for example, you have 1000 values, it will multiply with 1000. So for example, you want to take log, it can take log. You want to do the multiplication with big number, let's say 35, or any big number, you see just how fast it is multiplying. So this actually tables, that arrays that are used in the data science when you analyze the data, whatever data you have. And we will learn that we will use the petroleum engineering data in the upcoming lecture, but this is just an introduction that how you can put your tables and data here and then later on use it for your purpose. Now after we learn the command of simple arrays, then you have another reshape command. Third command is putting the series numbers. For example, now you have numbers from 1 to 0 to 20. So you can just write np.arrange and it will make the number for it. For example, you have 40 numbers. So you see now start from 0 ends with 39. So it gives you the value. Or for example, if you have 400, it again gives you the answer. It starts from 0 until 399. You can develop your table. And later on, if you want to multiply with it, you can still do it. And let's see how we can do that. So now what we did, we just set up a formula here, f is equal to r multiplied by 4. So whatever the values were, we showed you from 0 to 399. What it does, it multiplied all the values by 4. For example, it was 0 multiplied by 4 is 0. 1 multiplied by 4 is 4. 2 multiplied by 4 is 8. So and then it just printed all of it. So by using these tables, you can put all your data and you can do all the multiplication, division, plus minus, whatever you want to do ahead. So now let's look ahead at the further commands. Okay, there is one more command which is good for which is used in the NumPy. It is the selection. For example, now you have big this table. You have table from here till here, till here actually. Now you don't want to select all the, you want to do the multiplication, but you don't want to select all the numbers. What you want to do, you want something to multiply from the first one till the this one. Let's say 1 2 3 4 5 6 7 8 9 10. So this is called the slicing, exactly from where you want to start and where you want to end. So in this case, what we do, we put any other variable here d, and we select the slicing of the this f. So for example, you want to select from 2 to 20, and we use the print command, which is used to show the output. So when we run it, this is your original value, and now this is the table which you selected. Especially from out of this table, you selected the values starting from the 2 and 220. For example, you want to select it till 30, and you run it. Here you get the values here, and again you can do all the multiplication, division, and I will show you. So you can do all the comparisons here. You can do the arithmetic operations, you can use the exponential, you can use the trigonometric, hyperbolic, bitwise operations, logical operations, and so on. So you can do all the comparison and calculation based on this one, and it is very important when we use all the mathematical and equations and solution numbers, and you have the reservoir engineering problems. You can, NumPy is one of the main tool that you are going to use in the upcoming uh, uh, solutions. So now let's move toward the another library that we have, and it is called the Scipy. So we will see that how it is going to help us in solving the differential equation, linear equations, and so on. Now, when we talk about the differential equations or linear equations, the symbolic use, for example, how you are going to write x square in Python, or how you are going to x square plus y square in Python. So for that, we have a library. We call it a Sympy, and we call it a symbolic computing. So let's start with the symbolic computing and see how we can use the symbolic computing here. And let's look at it. The first one, for example, how we are going to write the x square or y square. So let's see how we are going to do that. Okay, so how you are going to do that, first of all you have to import the library Sympy. Okay, then whatever variables you are using in differential equation, linear equation, you have to describe them first. For example, sympy.symbol x. And likewise, for example, you want to define the y, z. So here you can define the y. Unless you don't define them, you cannot actually use them in your calculation. So let's look at it, how we are going to do that. First, you have to define, import the Sympy, then x, y, z, define it, and then we can use it. Look at this one. For example, you want to define the under root x square. So here you can define, or you can define x square plus y square. So you run it now. You see x square plus y square, or you want to define plus z square. Here you can see. So now you can define x square y square plus z square. What you did first, you imported the Sympy library. You define your symbols, x symbol, y symbol. Make sure this s is capital, otherwise it will show error. For example, look at this one. I make the small s and I run it. You see there is error. So this s has to be capital, else it will show error. So now you see you can define your x square y square like in a mathematical form. You can describe it, and you can again follow and do your calculations, so on. So let's go ahead with the further. Now we will define the functions. For example, f of x, y of x, and the in differentiation we have to define the function. We sometimes we have to take the limits. So now we will define the function f of x, y of x, and z of x, and see how we are going to do this. First of all, again, you have to define your symbols, and then you can proceed further. So let's see how we can do that. In the first step, we imported the Sympy library, then we defined the x, then we defined the y symbol, then we defined the z symbol, and now we will use the function command. And now let's see how we do that. Here you can see now. So in order to define the function f of x, we have the command sympy dot function. So what we did here, f is equal to sympy dot function, and we define f command here, and then you write the f of x. Here you can see you get, and or you can write the f of y. See f of y. You can write the z. That's how you can define the function. So here you can define that f of x, f of y, f of z. So you can define your functions. Remember what we are trying to do here, solving the linear equation, differential equations, and integration, derivation, and partial differential equation. So first of all, in order to define them, we have to learn the symbolic computing, how we can define their how we can actually put them in the Python software. So here you can see first you did the import sympy, you define your symbols, and then you use the function which is showing the f of x, f of y, f of z. We will go further and solve them further. Now let's look at the lambda function and how we can use this lambda. Now lambda is like a function for whatever function you have. You can set up the function and solve it accordingly. Let's look at it how we can use it. For example, here which is equal sympy dot lambda. You have to define the first value, okay, which is let's say the x, and what you want, what is your function, which is let's say x cube. So now whatever you want to define, let's say now you want to check for 2. So you run it. It says invalid context. First you define the h. So actually the problem was here, I didn't put the t. So a small error can give you, a small mistake can give you an error in programming. So the problem here was d, so now I solve it. So we are using the lambda function, h is equal to sympy dot lambda, and what we want, our function is the x is power cube. You can also change it to any power you like. And later on, you want, if you want to check, let's say the value of 4, you run it, give you the answer. You see now, you set up the function here, whatever your function was, and then it gives you the answer. Furthermore, if you look at it, for example, your function is 1 plus x. So now let's look at what it is. See, now it gives you the output like you are using the mathematical software. So this is, we call it a symbolic computing. We are just showing how to symbolically show the mathematical symbols in Python. Now furthermore, let's look ahead, and we use this symbolic computing further to write down an equation, a linear equation, or any equations you like. For example, we have expression 1 plus x 2 plus y 3. Let's run it. Run. The word expression is not defined, so sorry, in this case we forgot to put this is equal. So now you can see your equation is defined. Likewise, if you want to for the second one, we want to put 3 star. So now 3x square plus y cube plus 1. And likewise, if you want to plus z power 6. So now you can define it again. Z is not defined here. It is capital. We have to write it smaller. Now you can see here your equation is defined. So by using the symbolic computing, you can define it. Now the next step is you can do the integration of it. You can do the derivation of it. But first step is to define the equation symbolically, how you are going to define it. So now we have set up an equation, and now we are able to do this further mathematical solutions on. Now let's look ahead and we try to solve the we want to simplify the algebraic equation. This is the first thing that we do when we are in class 10 or class 12. We try to simplify the equation. Let's look at it for first of all now, that how we can simplify the equations here. For example, now copy. We have equation 2 multiplied by x square minus x plus x squared, for example. This equation here, if you write it, will appear like this one. Here and it. This is the equation. We want to simplify it. So let's, how we can simplify it? We have a command for simplification in Sympy, and so here we can write Sympy dot simplify expi. Here you can see. So we just simplified the equation. The original equation was, you cut it. This was the original equation. So when we simplify it, we use the command, and here you can see this is the final simplification. So you have any algebraic equations, you can simplify just by using the simplify command. That's the first thing. Okay. Now we have another expressions. We have expression of this one, and we want to cut it and express it. So we have 2 sine x cos x. We want to simplify this equation. So let's look at it. Sine 2x. So you can simplify your function, trigonometric function, algebraic equations, you can simplify them easily. Furthermore, now we have any other equation which is the expansion of the algebraic equations. Let's look at it how we do that. For example, we have an equation expression is equal to x plus 1 multiplied by x plus 2. If we define them, it will be x plus 1 bracket and x plus 2. How we can simplify, expand them? For example, we have to multiply them. How we are going to do that? For that, we have a command called expand. So what we do here, we use the sympy dot expand expr. We run it. So now you see it is expanded. Previous one was to simplify it. This one is to expand it. What we did, we just multiply. Let me show you again. Original equation. The original equation was this one. After we multiply, this becomes, we simplified using this one. So when we started the lecture, we started from the Numpy, we discussed the arrays, then we discussed the symbolic computing, how we can define the basic symbols in the Python, which we said we are going to use the Sympy library. So here you can see sympy.function, sympy.lambda, which is to period any function into it. Here we said that x tends to x power 4, and then we try to solve it with anyone. It shows us, for example, here for example shows x power 4 and the value of x is 6, so it gives you the answer directly here. Then we go ahead, we said we have expression, how we can define the expression. So we define the expressions, then we actually expand them. This is how we can expand them. We use the expand command, and then we can simplify them also at the same time using the sympy.simplify. Sympy.simplify SPR. So this is the simple. So here you can see now it is simplified. So defined, expression defined, simplified, expansion, and so on. So now you can see that we can define the algebraic equations, we can simplify them, we can expand them, and we can express them here. So we will end the lecture here. In the next lecture, we will talk about how these equations can be used in derivation, integration, and how we can solve the limits, and how we can define the partial differential equations here using this one. So all I want to say, if you want to learn Python, please practice. Do not look at the video only. You need to practice yourself, because there are simple dot is going to ruin your program. So better you practice and just practice. Then you can be a very good programmer of Python. And see you in the next video.